Welcome back. We're going to start learning about volcanoes today. We're going to look at the types of volcanoes and how volcanoes form. What is the situation you'll find yourself in if you were to have a new volcano show up? We've looked at volcanic rocks. We've looked at igneous rocks. We know that they were melted, so we have something that has to be hot that wouldn't be enough to melt rocks, and then those molten rocks find their way to the surface. So that's the easy part. So let's look at some of the details. Magma is melted rocks. When magma liquid rocks come out of the ground, they're called igneous rocks, remember, and they're extrusive rocks. They would cool down quickly. You would have different grain sizes based upon how fast they cool down. You're also going to have other things in with that magma. You're going to have water, a lot of steam. You're going to have other gases. You're going to have some sulfur gas, and you're going to have some carbon dioxide gas and some other gases that are trapped under the ground that were part of the chemical makeup of the rocks. And then as the rocks melt, they might decompose into some gases. Those would come out. So water, gases, solids, metals, along with whatever is in the rock itself. So volcanoes occur because of the plate tectonics of the Earth. For instance, if you have deep rocks, they are going to be closer to the mantle. They may be in the crust, but they might be very close to the mantle, and that mantle is heating it up and actually melting those rocks. So you could think of that as a hot spot. You can have hot parts of the mantle coming up due to convection currents. Hot will rise up towards the top and then sink lower when it cools off. Those convection currents can cause volcanoes. So a hot spot volcano doesn't have to be. It can be anywhere in a plate. And wherever you're going to have plates come together or pull apart, you can have volcanoes. So as two plates are coming together, magma will come up between those two plates and fill in. That's a volcano. That would be called a rift volcano. And when you have a subducting plate, where you have one plate going under another plate, well, that rock that's being dipped farther into that hot area can melt, and then that melting rocks can move upward and form a volcano. So there's various ways that we'll look at of production of volcanoes. Where you would find volcanoes is where you would find the plates coming together, because even though that there are hot spots in between a plate, so for instance Hawaii is nowhere near a boundary of a plate, but yet Hawaii, that's volcanic, so you can have them as hot spot volcanoes halfway across a plate, but most of the volcanoes in the earth are found on edges of plates. Okay, so two plates either pulling away from each other, getting some kind of a rift volcano, or subducting underneath each other, which is your main cause of volcanoes. So if you were to look at the main number of volcanoes here on this map, you're going to see that most of them occur on a continent near a boundary with an oceanic plate. So the oceanic plate is being subducted underneath the continent and then melting, and then that melting rock that's finding a way up will form a volcano. And so you're going to have volcanoes along the east coast of Asia, along the west coast of the Americas, and along the island coasts of two plates coming together, those boundaries. All right, so let's look first at convergent. So converging, remember, means come together. So if I have the ocean crust, which is more dense than the continental crust, that means the continental crust is less dense, it will float. So the oceanic crust will actually, if you're forcing them together, the oceanic crust is deeper because it's denser, and it will start sinking underneath the continental crust. So for instance, if you have California or the western coast of South America, you're going to have the entire ocean, the Pacific Ocean, crust is going to be shoving underneath the American continents. And so when that happens, that will melt. It'll melt those rocks. And because they are molten, they have enough energy to well up and form volcanoes. So a lot of times volcanoes form not exactly at the boundary, but on the edge of the boundary where the oceanic crust is subducting underneath it, melting, and then coming up and forming volcanoes near the coast. So these belts of volcanoes, many are around these oceanic subduction zones. And so the biggest one is the Pacific. This is called the Circum-Pacific Belt. And a lot of times people will refer to this as the Pacific Ring of Fire because of the volcanoes. So because these oceans are sinking down underneath the continents on both sides, you're going to have volcanoes all the way up the coast on both sides and down along the volcanic islands in above Australia. You're also going to get one in the Mediterranean. Okay, you've got a Mediterranean, you've got boundaries between several different plates shoving there. You have an Arabian plate, you have an African plate, you have a Eurasian plate, and because they're shoving together, you're ending up with volcanoes there. So it's much smaller than the Ring of Fire. The Ring of Fire is the biggest belt of volcanoes in the world, but you do have some substantial ones, say in Italy. You have Vesuvius, remember, that erupted in, I think it was AD 79, completely covered Pompeii. You have Etna and some of those other South Italian and the different islands in the Mediterranean that are all volcanic islands. You can also have volcanoes when they pull away, so divergent. Divergent means the plates are pulling from each other, and when they do that, they leave a crack, and the crack is filled with magma. Magma will rise up from the bottom and fill in that crack, and that is a volcano. That's by definition what a volcano is when molten rock comes up to the Earth's surface. Now, even if this is under the ocean floor or under the ocean waters, it's still a volcano. It would be pretty dramatic to see what it does to the water, but that is called divergent volcanoes. You're also going to have a third kind called hotspots, and a hotspot is normally not at a boundary, but it is somewhere in between a plate, and essentially you're going to have a plume. You're going to have an area of the magma, or this is deep solid rock, but that the magma underneath it has been able to melt some of that crustal rock. So this is deep crust rock that is close enough to a hot spot in the magma that it's melted, and then that is forming a volcano somewhere. And you're going to see this a lot, like Hawaii. Hawaii is a hotspot volcano where there's a plume of magma, and then as the crust moves, as the ocean crust moves, you're actually going to get one volcanic island after another in a line. And so as the oceanic crust moves, because it is moving to the east and the west on both sides of its rift, wherever that island is, the hotspot stays the same, and so as it moves, you're going to get a new island formation. So Hawaii is actually a little string of several islands, each of them volcanic. Okay, so you can kind of see that as in this picture, you're going to have a movement of the entire oceanic floor moving towards the northwest, but the magma hotspot is the same. It is basically a hotspot that is deep in the crustal in the exchange between the crust and the mantle, and it stays put, and so you end up with more than one volcano in line. So sometimes this forms chains. So you've got Hawaiian islands, but then you also have other islands, and then you have the Aleutian Islands. All of this is formed from hotspot, where you have one location of a hotspot, but then the ocean is actually moving, creating more than one island in a chain. Takes a long time. Another interesting fact, if you're a geologist, is that whole big patches of rocks in the middle of, say, Oregon are made out of basalt. And basalt is the rock that's at the bottom of the ocean. The ocean floor is made out of basalt rock. It's the runniest type of lava. And so if you have an oozy volcano that erupts and then covers the ground, you can end up with basalt rock. So these are called flood basalts. So lava flows out of a crack, so there's a crack somewhere. It oozes a volcano rather than a little mountain volcano. You've got kind of a cracky volcano. Imagine a boiled egg with a cracked shell, and everywhere along that shell you're getting ooze. That's the runny volcano. And so these are fissures. These cracks are called fissures, and they can ooze lava. And then when the lava hardens, you're going to have whatever type of rock that happens to be, in this case, basalt. So this is in Washington, Oregon, the Columbia River Valley. All of this is basaltic rock. So that meant that there was a break somewhere in the Earth's crust ages ago, and the magma from underneath the crust has oozed up and filled in, essentially ran over whole floodplains of oozy volcano magma, lava, that then hardens into rock. You also have a huge section in the Deccan traps in India, which is also a basaltic type of oozy lava that's that there's been a crack in the Earth's crust, and then the lava has come out. Okay. All right, so the parts of the volcano. The part where the lava actually comes out is called the vent. And of course, a vent is just anything that opens into something else. So you can have the gases come out, the ash come out, the solids come out, the liquid parts come out, all of this would come out. There's a bowl-shaped depression at the top of the vent where the rocks will collapse in on it, and that's called a crater. And sometimes craters can be very large. If an entire top of a mountain would collapse, then what's happening is that the crater formed by the top of that mountain can be, miles across, and a lot of times that volcano will go dormant and then fill up with water and become a lake. And so these crater lakes are called calderas, and a caldera is simply a Spanish word for a big cooking pot. So it's like a large pot that then fills up with water. These are called calderas, and they can be a mile across. I've been on Lake Nicaragua, which was a caldera lake, and it's a huge lake. It's bigger than Summersville Lake, but it's was at one time the top of a volcano, which is pretty cool. Okay. Now, the kind of stuff that comes out of the volcano, the type of rocks that are melted, will determine what looks like, what type of a volcano it is. If it's just coming out of a crack, that's a fissure volcano, like the basalt floodplains that we mentioned a minute ago. If it's really, really runny, then you'll get a shield volcano. So all the volcanoes in Hawaii are shield volcanoes. If you have thicker magma, and you have more explosive type of volcanoes to where they'll blow their top, then you get more steep volcanoes. And so you can have a dome type of volcano, or you can have layers of, say, lava that hardens into a rock, and then ash that falls down on top of that lava. So the ash goes up into the sky, is suspended in the air, the lava runs down the side of the volcano, coats it, and then the ash falls back on top of it. And so if you were to cut into that rock, you would see layers of these types of volcanoes. So it depends. Do you have magma or not? So if you have lava and ash, then that's composite. If you have more of just cinders, rocky cinders and ash, then you have called an ash cone or an ash cinder volcano. And then remember, the caldera is one that's collapsed. So if you have a volcano and the whole top is kind of caved in on itself, where the roof of that volcano, the magma chamber caved in, that's called a caldera. So the rest should be a little bit of a review. The shield volcanoes are the runny types of volcanoes. So anytime that you're melting basalt, you're going to get shield. So this is all Hawaiian volcanoes or shield volcanoes. In fact, the entire island is the mountain. It starts at the bottom of the ocean floor and little by little comes up through the water until it breaks the surface, and then you have the Hawaiian Islands, which are actually the tops of shield volcanoes. Cinder cones, you've got pieces of lava, that's cinder, they break in the air, and this is roughy cindery rock, which is called tephra, and it falls down, and that's a cinder cone. And then we mentioned that the composite is these layers, either of ash and lava. And remember, the ash can have the rocks in it. It can have this cinder and tephra in it, so it's layers of oozy lava that hardens with all of this gritty, rocky, dusty stuff, so one after another. And these are called composite volcanoes. And these are more of what you think of. Kilimanjaro in Kenya would be a composite volcano. Now the largest volcanoes are these ones that are gentlest slopes. So Mauna Loa in Hawaii is miles and miles and miles and miles across, most of it being under the water. So these are the largest volcanoes, even though they're not the highest volcanoes.